Anyone want to correct branch definitions? Yes, loop is correct, but branch definition is wrong. Anyone wish to give answer for branch?
The junction points are not connected to each other.
Junctions point are not connected to each other. Still wrong answer. I need correct answer. Have you studied this term?
The connections between the nodes.
The connection between the nodes. Okay. Still something missing. Uh, okay. Is it visible, this presentation?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So the difference, main difference between sorry, branch, that is section or portion of the network, okay, that between that lies between two junction. But I just want to ask between loop and mesh. What is the difference between loop and mesh? Answer branch. The previous students that have given the correct answer for the branch. Now tell me the difference between mesh and loop. Anyone? Mesh and loop difference? Yes, Mehul.
Sir, loop is a closed path in a circuit where two nodes are not transversed twice,
Okay.
whereas mesh is a closed path in a circuit with no other path inside it.
Okay. So the main difference between loop and mesh. So any closed path in network is called loop, whereas mesh, it is the most elementary form of loop. Okay, it is the part of loop, but it cannot be further divided into other loops. Means we can't repeat loops in terms of mesh. Okay, suppose I am giving the example. Suppose I have one circuit. I have one EMF source here. Okay. This I am giving the name. This is A, B, C. This is D. Okay. This is your R1, R2, R3. This is your V. So, how many loops are there? How many loops are there? Anyone?
Two.
Three.
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 There are three loops.
Three.
Okay. Which
Three.
one? First one is A, B, D, A. Then second B,
B, C, D, B.
B, and third
A, B, C, D, A.
A, B, C, D, A. So there are three loops. And mesh means it is elementary form of loop, but can't further divide it into other loops. So how many mesh are there?
Two.
Yes, the answer is two. So the mesh is A, B, D, A, and second is B, C, D, B. Okay, and this A, B, C, D, A that we can't consider in mesh. Okay, so whatever loop that we consider, so that we can't repeat or that we can't consider in terms of mesh. So this is the main difference between loop and mesh. What is the statement of KCL and KVL? Anyone want to give the statement? first Kirchhoff's
Sir,
current.
for KVL, the algebraic sum of the potential in any loop must be equal to 0.
Okay, mathematically, how we can write this KVL? Mathematically, suppose we want to write.
Sigma V is equals to 0.
Okay, first I can write sigma V is equal to 0. Then in second, in other words, suppose I want to apply KVL in a network or circuit, then how I can write it mathematically? So it can be written as sigma IR plus sigma EMF is equal to 0. So KVL states that algebraic sum of product of current and resistance plus algebraic sum of EMF is equal to 0. So here I use the word algebraic sum. Okay, so this word is important when we apply KVL, when we have only resistive load connected. Resistive load connected, so we need to use this algebraic sum. If we are having RLC load connected in AC circuit, so we need to use vector sum, or this combination of load is called the impedance. So when we need to consider impedance, then we are using vector summations. When we are having only a resistive type of load, then we need to consider algebraic summations. Okay. And what is the statement of KCL?
Current entering in the circuit is equal to current leaving the circuit.
Yes, good. Circuit should be closed or open? Circuit should be closed or open when we apply KCL?
It should be closed.
Yes, it should be closed. So when you state KCL, then what you have to say? In any closed path of circuit, the sum of entering current is equal to sum of leaving current, or the algebraic sum of all the current meetings at a node is 0. Okay, so you want to state correctly. Okay, don't miss any word when you give the statement. Okay. Have you studied series and parallel connections?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
What are the disadvantages of series connections?
Overloading.
If only one resistor of series connection,
Yes.
series નો કોઈ પણ એક અવરોધ પણ કામ કરતો બંધ થઈ જાય તો આખી series બંધ થઈ જાય, આખું
Yes.
circuit બંધ થઈ જાય.
Yes. If any failures or there or any break occurs in the series circuit, so no current will flow. So your entire circuit that becomes useless. Okay. And second disadvantage is, yes, overloading. Suppose we have only rated voltage. We have only rated voltage, or you can say supply voltage, that is only we have for single phase 230 watt. Suppose we are using 3 lamp, each rated each each rated of 230 volt, then it becomes 3 into 230, so that is 690 volt. Okay, but we have only available 230 volt, so this is the main drawback of series connections. Okay, so we are not using for domestic and power wiring connections. So for that, we need parallel connections. In parallel connections, if any break or failure occurs in circuit, so your circuit will not disturb. Okay, other branch will work. Okay, and in parallel circuits, all appliances are work at rated voltage, but due to having the different power rating, it can work without affecting the other appliances. So we can switch on and off any appliances without affecting the other appliances. So that's why for the domestic and power wiring connections, we are using parallel connections, whereas for series, we are using low voltage lamp. We are using low voltage lamp for decorative purpose. Okay, so for low voltage lamp, we can connect in series connection due to having the uh, low voltage ratings. Okay, so for decorative purpose, we are using series connections. And suppose you want to control the fan, so we are connecting in fan regulator. So regulator that we are connecting in series with fan. Okay, so these are the applications of series connection, and for domestic and power wiring connections, we are using parallel connections. Okay, now we are moving to the star delta transformations. Okay, have you did the example of series and parallel connections? Examples of series and parallel connections?
Yes, sir.
Yes, sir.
Okay, you already also did voltage divider rule and current divider rule, I think. Completed? Voltage divider rule, current divider rule. Current divider rule can be applied in which circuit? Series or parallel?
Parallel.
Current divider rule
Parallel.
in parallel. Okay. And
Parallel.
voltage divider rule?
Parallel.
Series.
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 And an example in that you need to apply current divider rule and tell me the equation for currents. Okay. Just I am giving you one example. I have the circuit like for the extension connection is given here. This is your IS, I1, R1, R2, R3, R4. This is your I2. Apply current divider rule. Tell me the equation of I1. I1 is equal to I1 is equal to, according to current divider rule,
IS minus
I
I2.
R2 R1 plus R2.
one by one. I1 is equal to, so this is a parallel circuit, okay? R1 and R2 that is connected with parallel with R3 and R4. Suppose I want to find I1, then you need to consider opposite branch resistor. To find I1, we need to consider opposite branch resistor. So in opposite branch resistor, we have R3 and R4 resistor, but both are connected in series. So I1 can be written as R3 plus R4 divided by sum of resistance into IS. Okay, good. Tell me the
Yes, sir.
equation. Tell me the equation of I2.
R1 plus R2
R1 plus R2
divided by R1 plus R2 plus R3 plus R4 into IS.
to IS. Okay. Suppose I am having only R3 register. I am cancelling R4. So the equation of R3 will be equation of I1 will be, suppose I am having only one register. So it becomes
R3 upon R1 plus R2 plus R3
same.
into IS.
Same. I am cancelling this R2. Then it becomes like this. Okay. So this is your current divider rule. Okay, so this is for series applications, I1, I2, that is your supply current, total current. Okay, this I equal to I1 plus I2 due to the KCL, okay. Algebraic sum of current meeting at a node. This is voltage division rule. So suppose you want to find V1 across R1. So this particular R1 resistor, R1 divided by sum of resistance R1 plus R2 into Vs or V. So that is your V1. And V2 is equal to R2 divided by R1 plus R2 into V. And this V equal to V1 plus V2 according to the KVL. Okay. And in series circuit, voltage remains different. So we can write V equal to V1 plus V2. Now star delta transformations. So to solve the complicated network or circuit, we need star delta transformations. Okay. We can't solve by series and parallel connections. Complicated networks. Okay, so for that we need star delta transformations. So when you converting star to delta conversion, so you can see this is your star connections. Okay, this is your star connections. So in star connection you can see one common point is there. For this ABC point, one common point is there. So this is your star connection. In delta you will not having any common point. Okay, it is a closed circuit. So it is called a delta connections. Okay, so whenever in circuit you are identify this type of network, the star, then to for simplification of circuit you need to convert into delta. And when you want to simplify the circuit, when you see this delta connection in the circuit, so you need to convert into star accordingly. Okay, to get the equivalent resistance equations to find the total circuit current, so either you need to convert star to delta or delta to star to simplify the circuit. Okay, and generally we are converting in clockwise direction when we converting star to delta or delta to star. So just we are moving to the equations that you need to remember for solving the examples. So this is the star to delta conversion. So when you converting this star to delta, so A, B, C, 3 points are given. So 3 raised to RA, RB, RC is given. So when we converting into clockwise this ABC, so this is RAB, this is RBC, and this is RC resistor. Okay. So to remember this conversion star to delta, so you can see here we use RAB. So we have only two resistors. Same here RBC and RCA. Third one is missing. Okay. So for that just you need to remember RAB is given. So RA plus RB plus multiplication of two resistors RA, RB and divided by third resistance. Okay. Same for RBC. RB plus RC plus RB into RC divided by third resistance. And for RCA, RC plus RA plus RC into RA divided by RB. Good. Anyone having doubt regarding to these equations? Already proven, okay? Just you need to remember.
Okay, sir.
So this is the conversion of star to delta. So you need to summation of two resistor plus you need to multiply two resistor divided by third resistance. Okay, for RAB, RBC and RCA. So this is your star to delta conversion. So you can also write these equations. After this, we are going for examples. So in that you need to apply these equations to get this RAB resistor, RBC and RCA resistor. Okay, so along with me, you can write in your notebook. So it will be helpful in for solving examples. Okay, so if anyone having doubt regarding to this conversion, just you can easily remember this. Okay, for RAB, RBC, just you need to addition, multiplications. Okay, similarly you have to follow for the registers. Okay, and in delta 2 star, you can see this RAB, RBC and RCA register is given. So in clockwise, just we are arranging this. This ABC point is given like this. So it is given A, B, and C. Okay. If your delta is given like this, this is my A, then this is my where I can write B. Suppose I am writing this is B and this is C. So my star will be this is your delta that is converted into. Now I have delta like this, and then your star becomes like this. Okay. You can also, according to circuit requirement, you can also convert like this into star. Okay. So this is your also star. I can also write this star into like this. This is, so according to the circuit connections, for simplification, you need to draw this star connection. It is not necessary just you have to draw like this only. This is also star. You can see this common connection. Are you getting this? Everyone?
Yes, sir.
So that we will see this conversion. According to simplification, you need to draw in circuits after simplifications. Okay. You will be also delta like this in circuit. You will also delta like this in circuit. Okay. So accordingly, you need to write the equations. Okay, like you can convert into like this. Okay, or you want to convert like this according to delta given. Okay. So in conversion of delta to star, so you can see the clockwise, the arrangement is here. You can see ABC is given, this is RA, this is RB, this is RC. So you need to remember for delta to star conversion, you can see this with A, with B and with C, the resistance connected with ABC. So you need to do multiplication divided by total resistance. Okay, so I am converting delta to star. So with A, how many resistors are connected? With A, how many resistors are connected?
2.
With RAB
Two.
and RCA. So we need to do multiplications. So RAB into RCA divided by total resistance, summation of total resistance. Okay, with B, RBC divided by summation of total resistance. And for C, we have RCA into RBC divided by sum of total resistance. Okay, so this is the delta to star conversion. Okay, so anyone having query regarding to this conversion, how to remembering it?
No, sir.
No, sir.
Okay, just you can see we converted clockwise this A, B, C, and you need to multiply with whatever resistance connected with ABC while converging of delta to star. Okay, in star to delta, we are doing the summation into a plus multiplication divided by third resistance. in star to delta. In delta to star, the resistance connected with ABC point, just we need to do multiplication divided by summation of total resistance. Okay. Now we are moving to the example. Okay, this is the series parallel connections. Okay, uh, in examples, in exam you will be asked the sum. Suppose sum is given, just you need to solve by star delta, by using mesh analysis, by nodal analysis. So whatever the statement is written, according to that you need to simplify. Okay, in between you can do series parallel connections. Okay, now this example is given, but here we star data transformation. You can easily solve by series parallel connection. This already you did, okay? This series connection, 50-50, 100 series connections, that is in parallel with 50 ohm and 100 ohm. So you can see here, series connection, series that is in parallel with 100. Okay, so this is parallel connections. So we'll get the answer like this. This is again series connection. So now this becomes in parallel. Okay, again this is in series connections. Now we are getting this in parallel. So we'll get the equivalent resistance 50 ohm. So we have V and R. So according to Ohm's law, you can write I is equal to V by R. That is 2 ampere. Okay. Now,
સર એકવાર સમની સ્લાઇડ ફરી ખોલજો ને.
okay. Okay, this is your example. Now you have here 1, 2, 3, 4 data are given. Okay. But suppose if there is no need of star to data conversion, then don't go for star data conversion. Okay, just you can easily solve by series parallel connections. So this is 100, this is 100. Okay, in series connection, this 100 and 100. These 50 and 50 are in series connections. Okay. Now next step. So this 100 series, 50 50. So this is 200. This is 100. Okay. Now this 200 and this 100 that is in series with this 50 ohm and 100 ohm. Are you getting this?
Yes, sir.
Okay. Now do the parallel. Okay, this 200 and 50 and 100 and 100 parallel connections. So you'll get 40 and 50. Okay. By solving these parallel connections, you are getting here, you can see 200 into 50 divided by 200 plus 50. So 40 ohm. This 100 into 100 divided by 100 plus 100. So that is 56 ohm. So just at the downward, you have only two resistors. Okay. So this 40 and 50. So this is in series connections. That is 90 ohm. Now this 90 and 90 in parallel. Okay. So that is 45 ohm. 90 into 90 divided by 90 plus 90. Now this 45 and 55 in series connections, that is 100 ohm. Now that becomes in parallel with 100. Okay, this 100 and 100 parallel, that is 50 ohm, 100 into 100 divided by 100 plus 100. So now you have only 50 ohm. Okay, good. So this is your total circuit current. Now here it is mentioned using star delta transformations, determine the resistance between the terminal A and B in the given circuit. Okay, so in the circuit you can see the resistance arrangement are given. So already here in diagram it is shown delta connection is written here. Okay, so this delta we need to convert into star. This delta we need to convert into star. So you can see how to convert this delta into star. So we have given already the name ABC. Okay, so this ABC delta like this. So we can convert this RA, RB and RC like this. You can see this 1 point is given and two resistance are connected. So a reverse delta is given. Okay. So for the reverse delta, I already told you, you can draw diagram like this. Or according to circuit requirement, you can go for like this. Okay. So that we are going to do after solving this. So this delta is given here, ABC, okay, and converted into RIB, RBC, RC. So you know, for RA, when we are converting delta to star, so for RA register, 20 into 5 divided by sum of total resistance, 20 plus 5 into 50. Are you getting this answer? 2.5. When we convert delta to star, then whatever resistance connected with A, B and C terminal, you need to do multiplication divided by total sum of resistance. Okay. So RA can be written as this 20 into 5 divided by 20 plus 5 into 15. For RB, tell me the answer for RB. RB is equal to 20 into 15 divided by 20 plus 15 plus 5. So answer will be
7.5.
7.5.
answer is 7.5. Good. And for RC, 5 into 15 divided by 40. So RC is equal to
1.8.
So RC is equal to 1.87 ohm. Okay, so this value that we need to connect in simplify in the circuit. So your circuit becomes like this. So you already have, okay, so this 2.5, this 7.5 RB, and this is your 1.87. Now all your diagram is like this. This is your earlier diagram. You have 10, 2 and 5. Now this delta converted into star. So you having RA, this is RB and this is RC. Okay. So it is connected like this. This is your 2.5, 7.5 and 1.87. Now this dash portion, that is series connection. This is series, and this is series connection. So 10 plus 5, 15. This 10 plus 2.5, 12.5. This is 3.87 and this is 37.5. So you can see 12.5, 15, 3.87, 37.5 and 30. Okay. Now what we will do next? Anyone? Next step will be, any series connection is there in this diagram?
12.5 and 15 and 37.5 and 30.
Not series connection. You can see one further connection is given in between.
Yes.
So that is not series connection. If you are not having this connection, then you can do series connection, but you have further connection is given. So this is not series connection. This is also not series connection because you have circuit extension is given here. Are you getting me?
Yes, sir.
You can see here this 7.5, 5 and 2.5. So that is connected in series. There is no in between connection is given. Okay, there is no terminal is given. So that's why we connected in series. Okay. Same this 10 and 5, there is no any extension connection is given in between. That's why it is in series. But this 25 and 30, that is not series connection because one extension connection is given. So what we will do next? Anyone?
Delta to star.
Delta to star.
This 1, 2 and 3 is given, that is your delta. So convert into star. So tell me this value R3 register. R3 will be, so R3 will be, we are converting delta to star. So R3 will be, R3 is equal to 12.5 into 15
Into 15.
divided by 12.5 plus 15 plus 3.87. So this R3 will be same, R1 equal to 12.5 into 3.
5.98.
R3 is equal to 5.97. Okay. R1 equal to 12.5 into 3.87 divided by 12.5 plus 3.87 divided by 15. So R1 equal to
1.54.
R1
1.54.
1.57. Okay,
44.
1.54, and this R3 equal to 15 into 3.87 divided by 15 plus 3.87 plus 12.5. So R2 equal to
1.85.
1.85. So this converted into star. Okay, so according to circuit, you can see the data is given like this. So your star becomes like this. Okay, this is your third resistance, this is your first, and this is your second resistance. Okay, now any series connection is there? You can see this 1.54 and 37.5 are in series. Okay, this 1.85 and this 30 are in series. So this 39.04 and this 31.85 ohm. Okay, now this 39.04 and 31.85 now becomes in parallel connections. Okay, now this 5.97 and this 17.54 in series connections. So your RAB is equal to 5.97 plus 17.54 is equal to 23.51 ohm. Anyone having doubt in this example? Anyone having query?
No, sir.
Okay, we will. Okay, we will move to the another example, so we'll get the better idea for this conversation. Okay, so what we will do here? Calculate the current supplied by the battery in the network. Now you need to apply star data transformations. So to find the circuit current, we need to find the R equivalent resistance by using star delta transformation. So for the R equivalent, you have to get the resistance value, one resistance value. So by finding resistance value according to ohm, so you can find I equal to V by R. So what we will do here? We will do star to delta or delta to star?
Delta to star.
Yes. How many delta are there?
3.
Three are given, but by solving two delta, we will get the answer. So here A, B, C and C, D, E delta that we convert into star connections. Okay, then we will get the answer. So first we will solve this ABC delta, and then we will solve this CDE delta. Okay, so tell me the answer for RA when we solve ABC delta into star. So RA will be RA is equal to 2 into 4 divided by 2 plus 4 plus 6. So RA is equal to
0.6.
RA.
2 by 3.
Yes, RA is equal to, you can see this conversion. So RA is equal to 2 by 3. Okay. This RB equal to 2 into 6 divided by 2 plus 4 plus 6. So that is 1 ohm. And this RC is equal to 4 into 6 divided by 2 plus 4 plus 6. So that is 2 ohm. So this is RA, RB and RC for this delta connection. Okay. So, and this for CD delta for RC 2 into 5 divided by 2 plus 5 plus 3. For RE 3 into 5 divided by 2 plus 5 plus 3. And for this RD 2 into 3 divided by 2 plus 5 plus 3. So we'll get the RC is equal to 1 ohm, RD is equal to 3 by 5 ohm, and RE is equal to 1 by 5 ohm. Okay, so we solve here two delta. Now just we are implementing on circuit. So this is the reverse delta is given, and this is the actual data is given. So this is you can fit in the circuit like this. So this is your reverse delta. So this is 2 by 3, 1 and 2, and this is 1, 3 by 5 and 1.5. Okay, good. How this is run? This is your 1, this is your 3, this is your 1 by 1.5, and this is your 3 by 5. Are you anyone having doubt? How this is run? as you know, in circuit, as I told, if your delta is given like this, then you can draw like this. Okay, and if your delta is given like this, then you can draw like this. Okay, so accordingly this is drawn. Now this 3.5 and 1.5 in series connection, this 2 and 1 series connection. Okay, so this becomes 6, this becomes 3. So this is 6, this is 3. So this is in parallel connection, 3 into 6 divided by, okay, 3 plus 6, this is 3 plus 6. Okay, so that is 2 ohm. Now this 2 by 3, 3 by 5 and 2 ohm. So this is series and parallel, all three resistor.
Series.
In series, okay.
Series.
So many extension connections given in between that. Okay, so these all three are in series connections. So R equivalent is equal to 2 by 3 plus 2 plus 3 by 5. So that is 49.15 ohm. So this is our R equivalent. Now we need to find current in the circuit. So I equal to V by R equivalent. So that is your 49 supplied voltage, 49 divided by 49 by 15. So answer is 15 ampere. Okay. Now anyone want to solve this example? Determine the current in the 17 ohm resistor in the network shown below. You need to use star delta transformations. First step will be
Star to
Series
delta.
connection.
yes, 2 and 4 in series connection. This 4 and 11 in series connections. Now then your first step will be like this. This is series connections 2 and 4, and this is 4 and 11 series connections. Okay, so this is
Then we have two deltas.
yes, two delta. Then this delta convert into star. So this is your 666. So that is converted into star. Okay, so already inside one star connection is given that you need to that is equivalent to star. Okay, so this delta into equivalent star inside is drawn. Okay, so this all values are similar, so you'll get the same value for this RE, RC, RA, RF, RB, and RD. Okay, this 666 convert into star. So RE equal to RA equal to RC is equal to 2 ohm. 6 into 6 divided by 6 plus 6 plus 6. Okay, you'll get same answer or not due to having this same value of resistor.
Yes, sir.
Yes,
Same
sir.
answer.
And this RF equal to RB equal to RD equal to, what is the value of this? RF, RB, RD. What will be the answer?
5 ohm.
5. Okay, good.
5 ohm.
So this is your RF, RD, RV equal to 5 ohm. Okay. Both delta converted into star connection. So already you can see this diagram. This is your two resistor. This is one end that is connected with A, and this one end connected with B. Okay. So now your diagram becomes, so in exam you need to show this all transformations. Okay, so you need to draw the diagram, and on side by side you have to show the calculations. Don't directly put the answer. You need to draw the reduced form of circuit diagram, as well as you have to show these calculations. Otherwise you will not get full marks. Okay, in all the examples, whatever you ask, So accordingly, step by step, you have to show the calculations. If diagram is there, then you need to do the reduced form of diagram. Okay. Your diagram become like this: 2, 2, 2, this 41, 17, this 5, 5, and 5. Okay. So any series connection is there?
2, 41, and 5.
This 2, 41, 5 series connections. Okay. This
217 and 5.
17 and 5
217 5.
series connections. So our diagram becomes okay like this. This series connections. Now you have 48, 24, 2 and 5. Now this is in parallel connections. Okay, so the answer is 16 ohm. 48 into 24 divided by 48 plus 24. So now this all three becomes in series 2, 16 and 5. Okay. So here what we will get this, here we will get this total circuit current. This is equivalent resistance. Okay. This is your equivalent resistance of the circuit. 3 ohm. So we'll get the here current. Total circuit current I equal to V by R 1.5 by 23, 5 ampere. Now further ask, we need to find current through 17 ohm resistor. Here we found total circuit current. Now we need to find current through 17 ohm resistance is the same as the current in 20 ohm resistor. Okay. Why it is written like this? The current through 17 ohm resistor is the same as the current in 24 ohm resistor. Why it is written like this?
They are in
They are in
because they are in series.
yes,
Series.
Series.
so they are in series because you can see here this 17 ohm resistor, or you can say this 20 ohm resistor. Okay, both are in series. Okay, so according to the current divider rule, suppose you want to apply this. So I equal to 5 into 48 divided by 48 plus 24. Then you will get this. You will get 10 by 3. Okay. So current is 10 by 3 ampere through 17 ohm resistor. Okay. So anyone having doubt in this example?
No, sir.
Okay.
No, sir.
So if you are not having doubt, then just I am ending this lecture. Okay, wait for 1 minute. Okay, so you will be asked in exam, whatever example asked. So you need to just there will be mention by using star delta transformations, by using mass analysis, by using nodal analysis, by using KVL, KCL. Okay, by using by series and parallel connections. Okay, so accordingly you need to solve, and you need to solve step by step. Don't just directly put the answer. Okay, so for getting full marks, you have to show all the steps, and you will be given enough times. Okay, for internals you will be having 1 hour, for external you will be having 3 hours. So you'll be given enough time for solving this example and writing theories. Okay, so you may leave the sessions if you are not having any doubt or query.